This is The Selfish Gene by Richard Dawkins. If a superior creature comes, they're going to ask if we have found evolution. Also, the author wastes no time getting to his radical thesis. We and all other animals are machines created by our genes. But I have a question. Robots are robots. Their parts only come together to work, and it's just a block of metal and it doesn't feel emotions. It might seem like it does, but no. Humans feel emotions. I think we might be made out of parts, but we are much more complex. The author argues that natural selection operates at the lowest level. Genes are selfish because their only goal is survival and replication. Every move is a calculated one to ensure their survival. This section, the author shifts from the world of DNA to macroscopic world of behavior, also explaining that genes control our brains like remote programmers, and introduces one of the most famous concepts in evolutionary biology, evolutionary stable strategies, or ESS. But if genes are just molecules trapped in our cells, how do they control animals and humans like us? The author uses computer analogy to explain this. Genes can't react to the world instantly. Protein synthesis takes time. If a predator comes, that gene can't send out a signal. But like a programmer, they must write a highly sophisticated master program. So genes are the program and step back, allowing the brain to take over. How can a selfish gene cause an animal to altruistically sacrifice its life for another? This is explained using the theory of kin selection. A gene copies itself in a biological relatives, including strict mathematical measure for this denoted as R. Your identical twin, R, is 100% shared genes. Your parent, full sibling, is R, 50%. Your grandparent, aunt, uncle, nibbling, 25%. Your first cousin, 12.5%. From the gene surviving perspective, saving the lives of 3 full siblings is mathematically worth more than saving your own life. Therefore, a gene that programs an organism to die, saving its family, will increase the number in the gene pool. The author argues that while genes explain basic biology, it doesn't explain how human culture, language, and technology explained. To solve this, a brand new concept of cultural replicator is introduced. He needs a word that sounded like a gene, but related to an imitation. So he coined the word meme, coming from the Greek mimeme, meaning that which is imitated. Just like how a gene jumps from body to body, a meme jumps from brain to brain via imitation or communication. When a catchy tune, joke like 6-7, or trend or idea takes hold in your mind, it is paralyzing your brain, using it as a vehicle to replicate itself. Surviving memes has 3 qualities: longevity, fecundity, and copying faculty. Until this point, the author has treated the survival machine, the physical body, as a boundary where gene control stops. In this chapter, he completely breaks that down, introducing the idea that a gene phenotypic effect is not limited just to the body, but can extend far out into the environment and even into other organisms. The author uses examples of animals, like for example the cuckoo bird. A baby cuckoo hatches in a host nest, and like a reed warbler, and screams so loudly that the host parents are biologically wired to feed it, neglecting their own babies. The baby cuckoo uses its appearance to hack the host parent's brain. This part is a detailed extended edition of the book, providing an endnote and reflection, containing major scientific updates, self-corrections, and fierce intellectual expansions on how the theory has evolved. The author addresses the criticism that his use of selfish led people to believe genes possessed conscious, villainous minds, doubling down on the fact that selfishness is strictly a mathematical description of gene survival rates, not a physiological trait. The author introduces a beautiful optical illusion metaphor. A nectar cube is a line drawing of a cube that your brain can flip back and forth between 2 different orientations, explaining that the gene is like that cube. Neither is wrong, but looking at it from the gene's perspective unlocks answers to mysteries that our perspective completely misses.